Okay, here we have another opportunity to see problems on, no, it's not extra credit. Okay, opportunity to work on these problems and maybe tell, okay, I need to ask for help. Maybe yes, maybe no. So when we say that we understand this, again, you don't have to, you can say yes or no. You can just do a nonverbal response that no one else is going to know whether, oh gosh, I don't know if I should raise my hand or nod yes or thumbs up or whichever. So, the front row, if we had to work on this on your own, are we on the bus here? Front row. Okay, second row. Third row. Okay, so again, no one's really knowing how you're responding for this, whether, oh geez, people are looking at me saying, I don't get this. Well, that's an opportunity to say, maybe tell yourself, okay, I want to get some extra one-on-one help, which you can do. You can choose to do that, okay? So, I think, did we count how many problems that we did together in class? Weren't we up to about 15, 16? Now we're got to be in the 20s, I would think.
I'll count them.
Okay. So the reason I bring that up is those are possible missed opportunities, and is going to make you a better student. I'd like to think so, but this is the best way that I know how to teach you this content standards. That I'm doing my best to teach you these content standards. And just look at this. We have 18 students in here. We got 14 in the afternoon session. And the way that might not work for you, we can't do 15 different ways to teach this. We're doing the best we can with who we have in here and what we have in here in numbers. Just out of curiosity, did you come up with a number?
22.
22 problems that we've gone through, and we've worked on those together. Okay? Would it be fair to say that it's a choice not to do that?
Yeah.
Would it be a choice to ask for extra help? Is that a choice?
Yeah.
Yeah, that would be a choice too, I think. Okay? So, as we look at this, during a race, a Formula One race car, well, not driver, but the race car hits a wall with 99,180 kilograms per meter per second. What was the force on impact? If the car was traveling at 58 meters per second over a 2.15 second time frame or interval, or however you want to count that, and was moving at 41 meters per second before impact. Now, and this is why, if you choose to write these problems down, it's difficult now. The more work we do with that, I think it's going to be easier for you once you're responsible for this content on your own. Because some of you are probably working on these problems together, and that's fine. But you're still responsible for this on your own. Okay, so for the 13th or 14th time, see, that number keeps getting bigger too. You've read the problem. What is the next thing we should possibly do?
Figure out what we have.
Okay, so what do we know in this problem?
That we have the force.
Okay, we're looking for the force. What was the force? So that's what we're looking for.
The momentum of.
Okay, now it's important to, you're right, it's important to look and see what variables we actually have and how did you correctly identify that? Because you're right. Yeah, because when we look at the label, notice it doesn't say hits the wall with 99,180, excuse me. It hits the wall with a momentum of 99,180. So we recognize that as this must be our momentum. Okay, so we've got 99,180 kilograms per meter over second. So that's the number, but what variable is that? You could use m, but probably a lot of people would say p because it's a product of a mass times a velocity. What else do we know in the problem? Now, you're exactly right. So let's go ahead and put them in here. We're going to put both velocities. And when you read the terminology and read how it's written in the sentence, how would you know which one is a final, which one is an initial?
Final says was at.
Okay? Never thought of it that way, but you're not wrong. Okay? So we're saying this is the final velocity here. That would be correct. But how could you maybe look at this and say, I think this is our initial velocity? Well, by default, it has to be. If that's correct, how might you be able to distinguish that it was moving at 41 meters per second as an initial velocity?
Because it's before.
Because it was saying before impact. So before it hit the wall, it was moving at 41. So after it hit the wall, it must have been moving at 58. Now, you might be sitting there thinking, I have no idea how to distinguish that. Well, when we practice this, that's how we get better. And that's a choice to take part in that. So, 41 meters per second, that is our initial velocity. That means 58 meters per second is our final velocity. Is there anything else that we know in this problem? Okay, 2.15 seconds. Okay, do we possibly see a problem here? Because we're looking for this, right?
Acceleration.
Because we're looking for the force, right? What two things do you need to know to solve for a force?
Acceleration and mass.
Okay, and we've got three unknowns here. We're looking for the force, we don't have the mass, and we don't have the acceleration. So that's probably a pretty big problem. But with the practice that some of us are choosing to do, what might be your first step to, because we can't solve for force until we get these two first. So you can pick one or the other first. Just tell me.
Acceleration.
Okay, so we're going to choose to do acceleration first. You can do that. So you'd have to use your acceleration formula.
Which is final velocity minus initial velocity over time.
Okay, so that means we've got, since you say it's over time, that's got to be a fraction. So then our time is 2.15. And what goes on top? Now you got to write it correctly. Okay, 58 minus 41. And notice we're not doing any labeling on that over there because we've accounted for that right here. Okay, so then is there something else we should do with that formula?
Minus it and then divide it. 41.
Okay, so when you do that, you want to do this first.
Yep.
Okay, so then you could presume that's what, 17?
Yeah.
So our acceleration equals 17 divided by 2.15.
We have to
3.9.
divide it. We didn't divide it.
I know, I said 17 divided by 2.15. 7.90 meters per second squared. Okay, so now we've got our acceleration. But we still don't have our mass yet.
Presley Lucy to Mr. D's room, please. Presley Lucy to Mr. D's room.
But can we even find our mass? Yes, we can. How, you're right. How would you go about doing that?
Mass times acceleration, not mass.
With our, there you you go.
Divided by final velocity.
There we go. So our momentum formula says any product equals our mass times our velocity. This was given in the problem right here, okay? This was given. So now we can just set this up to solve for our mass. So let's do what the formula tells you to do. What goes on the left side of that equation? Not T.
Or F, I mean?
Not F. Your momentum, which we've established is 99,180. So then what's on the right side now? Now, I could just stand up here and work through this and just show, okay, this is how you do it. But I really don't think that helps you. Okay? So what about 58? You're right. It's on the right side. So we've got 58 here. Okay? Okay. So everything you have here is right. What's left over from this formula? Yeah, because we don't know what our M is. So how do we solve for our mass now? You don't want to subtract, you have to divide because this is a multiplication function. So therefore, our mass is 1,700 and that's not right. Yeah, I had 10,710. So, but thanks for your vote of confidence. All right, 1,710. Was there a decimal? No. Okay, so then that is measured in kilograms. So now that we've got these two, what's your final step then to solve for your force? Yeah, you can just multiply these two because now you can solve for force. Yes. Yes, sir. Okay, so yes, I understand. There's a glare here, so that's mass equals 1,710. Okay, it's something that students before you, they've had to deal with this too, and they've always told me, well, we survived. So, and I think we can too. So now when we compare how we started the problem to now where we're at now, maybe we're a little better off. So middle row, are we on the bus here? Can you speak for your lab partner?
Yes.
Okay. Okay, back row.
Can I get a drink?
Yes, sir. Okay, and then front row. Okay? All right. So we were promising you some time to work on your papers together if you wanted, or work on your own. Some people, is anyone done already? Okay. So therefore, the individual or individuals who have their hand up, they would probably be a good source to ask if you choose to do that. Okay? All right. Or else you can, maybe, I will stop this. Okay, so that's all I have. We'll catch up to you next time.